Good afternoon, everyone. So, in the last lecture, we finished multiplexer, and we have designed different types of multiplexer and demultiplexer too, and also we try to design a higher level multiplexer with the use of lower level multiplexer. So, if you remember, I asked you one question that how to design 8x1 multiplexer with the use of 4x1 multiplexer. Is it possible, or we need to do something in when designing for designing 8x1 multiplexer with the use of 4x1 multiplexer? First, you tell me, is it possible to design 8x1 multiplexer with the use of 4x okay, fine. How? Because the rule says you divide the higher order with the lower order till the time we get 1. Okay. So in this particular case, what we get in the first level of the division, what we get 8 divided by 4, we get 2. So according to this, further division is not possible. So what to do now? How many number of marks we need? 4x1. Exactly. So in the first level, what we have to do? In the first level, you will use 2 4x1 marks, and in the next level remains 2. So it shows that the next level, what we have to do, we need to use 2x1 marks instead of 4x1 marks. So you have to use your mind for a division. If at certain point you feel that further division is not possible, so you have to use some other marks. Okay, but in most of the cases, only one type of marks is sufficient to implement a higher order of multiplexer. So I think everyone clear for how to design higher order marks with the lower order marks. Is it clear to everyone? Okay. So we'll see. So in today's lecture, we will see how multiplexer can be used to implement any kind of Boolean expression. Okay. In the previous lectures, we have seen that for the implementation of the Boolean expression, we use various kinds of basic gates, XOR gates, or NAND gate, or NOR gates. Okay, but if we have multiplexer in our hand, so we can use that multiplexer for the implementation of any kind of Boolean expression. So for that thing, how to proceed, we will see today. We'll see how to implement any kind of Boolean expression with the use of multiplexer, and also we will see that just like NAND or NAND and NOR is used, it's called as a universal gates. We will see that multiplexer is also called as a universal combinational circuit. Okay, there is a difference between these two things. NAND and NOR is called as a universal gates, but here we will see multiplexer is called as a universal combinational circuit. Okay, so we'll see. We can't call this multiplexer as a gate, because multiplexer is the combination of different kinds of gates. So that's why we have categorized this multiplexer in combinational category, combinational circuit category. Okay, so see how to implement. You know that. Okay, then different higher order gates. We have implemented higher order of marks with the use of lower order of marks. So next here, whenever we have any of the Boolean expression, so what we see, Boolean expression contains different types of combination of variables in either in terms of the complement or uncomplemented. Okay, so first you need to see how many number of variables are there in that particular Boolean expression. So okay, if there are n number of variables in that Boolean expression, so what we have to do, we need to take n minus 1 variables as selection line, because if we talk about the multiplexer, what we have in the multiplexer, we have some input line, we have some selection line, and only one output lines. Among those different input lines, only one output line will be selected based on the combination of the selection lines. Okay, so for that thing, among those different number of variables, we need to find out which variable we will take as the selection line. Okay, so if there are n number of variables which makes the Boolean expression, we will take n minus 1 variables as selection line. This is the first rule. Okay, the remaining variable, so if from n number of variables we are taking n minus 1 as the selection line, so remaining variable is only 1. So the remaining variable will be taken as the input. Now what we have to do, we need to prepare the truth table. Okay, on the basis of the truth table, again we will modify that truth table according to the selection line, whatever we have taken, whatever variables we have taken as the selection line, according to that we need to prepare or we need to modify the truth table. So we'll take some examples for implementation. First, take this example. The variables are A, B, and C. So A, B, C. This is the simple example. Here, the function ABC, and it contains sum of 0, 1, 4, 6, and 7. Okay, this is sum of product. Okay, 0, 1, 4, 6, and 7. So according to the first rule, what we have to do, we need to take n minus 1 variables as selection line. So here, how many number of variables? N is equal to 3. So it means n is equal to n minus 1 is equal to 2 are the number of selection line. Okay, so now we know among those 3 variables ABC, 2 will be the selection line. Now we have to decide from ABC, these 3 variables, which one will be taken as the input and which one will be taken as the selection line. So it depends on you. So suppose we are taking BC as the selection line, okay, and A as the input. What rule says? From n variable Boolean expression, n minus 1 variable as selection line, remaining variable as input, prepare the truth table, modify the truth table. Next is here 3 variables are here. So here we are taking BC as the selection line. So the remaining variable is A. So the remaining variable A is A. So remaining variable will be taken as input. Okay. See how to modify the truth table. Here I have taken A dash B dash. Okay. So we'll see if we take DC. We'll take this example. Okay. So for this, first prepare. Next is prepare the truth table. So according to this truth table, min terms will be 0, 1, 2, 3, 4, 5, 6, 7. The 8 number of combinations for the 3 variables, 8 number of combinations. Okay. If next thing is that if we take n minus 1 number of variable as selection line, so on the basis of that thing, we have to decide which type of mux we need. Okay. So here, if n number of 1 selection lines are here, n minus 1 is 2. So according to if we say in are there, n is number of selection lines, so n is equal to 4. So which multiplexer we need here? We need 4 cross 1 multiplexer. Okay, for 3 variables we need 4 cross 1 multiplexer because 2 number of selection lines are here. Okay, clear? So now we have to prepare the truth table. So after the truth table, the 3 variables, 8 combinations are here. For those 8 combinations, this Boolean expression is true for 0, 1, 4, 6 and 7. Okay. For these 0, 1, 4, 6 and 7. Okay. So we know that for this combination we are getting 1 for ABC combination. Okay, so now how to modify this? This is for this example. In this example, I have taken AB as the selection line, C as the variable, C as the input. But now what we are deciding here, we are deciding that PC as the selection line. So for this case, what we have to do? We need to prepare. So what for BC, how many because BC contains 2 number of variables, so how many combinations will be there? For 2 variables, 4 combinations will be there. Okay, so for BC, if we take BC as a selection line, so B dash, C dash, B dash, C, B, C dash and B, C. Remaining variable will we take as a input. So remaining variable is A. So here this will be A dash, this will be A. Now we have to decide what min terms belong to which combination. So this is the 0. This will be 0, 0, 1. This will be 0, 1, 0, 2. This will be 1, 0, 0, 1, 1. 3. This will be 1, 0, 0, 4. This will be 1, 0, 1, 5, 1, 1, 0, 6 and 1, 1, 1, 7. Definition contains which min term. Okay. Now try to find out for what combination for which min term your Boolean expression is true. Okay. So if we observe this truth table, 0, 1, 4, 6 and 7. Okay. So we will encircle. This will be, this is 0, this is 1, this is 4 and 6 and 7. Okay. So now we have to we need to observe again this table. So if we see the first column, so we'll see in this first column both the component are encircled. If both the components are encircled, we will take that as 1. If 1 is encircled, then we have to see that for which input it is having a circle. So here among those two boxes, for A dash it is encircled, so we will take as input A dash. Here among those two components, for A it is encircled, so we'll take it as A. Again for this it is A. So the input will be 1 A dash A. For if we take B C as selection line and A as input. Okay, so the implementation will be like this. In the implementation, how many number of inputs? 4. Okay, this is BC. Okay, this is BC, and suppose this one, okay, this one is small a, B, C, D. So again here, if we take A, B, C and D. So small a belongs to B dash C dash, small b belongs to B dash C, small c belongs to B C dash, and small d belongs to B C combination. Okay, so for B dash C dash or A, what will be the input? 1. So we will connect 1 with this. Okay, for B, what is the input? A dash. So we'll connect A dash here, for BC dash A, and for BC this is A. So we'll short these two, then it will be A, and output will be F. So this is the implementation. For this, when we take AB as selection line and C as input. So for this, the minterms will be here, like see here, 0, 0, 0. So 0, 0, 0, 1. Okay, here 0, 1, 0. 0, 1, 0 is 2. Here 0, 0, 1. It is 1. Here 0, 1, 1. 3 will be here. Here 1, 0, 0 is 4. 1, 0, 1, 5. And 1, 1, 0 is 6. 1, 1, 1 is 7. So if we observe this modified truth table, after observing, if we notice the answer here for the first column, for this input, for this A input actually, if we observe, both the components are encircled. So for this, we'll take 1. Okay, if both the components are not encircled, we'll take input as a 0. Okay, if 1 is encircled, we need to see that which complemented or uncomplemented input is encircled. So here 4 is encircled and it belongs to input C dash. So this in will be C dash. Here again 6 and both are encircled. So 1. So 1, 0, C dash and 1. So here the implementation will be for 0, 1, 4, 6, 7. A will be connected to here. A will be input A will be connected to 1. D is connected to 0. C. A is 1. Will be 1. B will be 0. This will be 0. C is C dash and D is 1. Okay, so it will be connected to 1 is A is connected to 0, A is connected to 1, B is connected to 0, C is connected to C dash, we are taking as an input, D is connected to 1, and A, B are the selection lines. So for the selection line, if A dash, B dash is there, so it will be 1. If A dash B, it will be 0. AB dash, it will be C dash, and AB is equal to 1. So this is the Boolean expression implementation with the use of mux. Can you try to solve this 0 to 5, 7 when we take BC as selection line and A as input line? Try to find out what we should connect at the input of mux. First tell me what will be the order of the multiplexer for this principle. Tell me 0 to 5, 7. Can you try to solve this Boolean expression implementation? Anyone? No? Any doubt regarding how to implement Boolean expression with by multiplexer? CS19B1019. Tell me, any doubt? No? Am I audible? Anyone, please respond. Okay, so any kind of doubt regarding how to implement, tell me. If no, try to solve that example. Okay, example is this one. 0 to 5, 6, and the selection lines are BC and the input is A. Okay, so try to find out what will be the how we will implement. So first tell me what will be the order of multiplexer. Lokesh, tell me what will be the order for this ABC if the number of variables are 3. 8 cross 1. How? You have to implement with the use of multiplexer, and I have already said that. I already said yes. 4 cross 1. Exactly. If number of variables are n, so what will be how many number of selection line? N minus 1, n is equal to 3, so 2 number of selection line. Yes. So now tell me, if BC we have selected BC as the selection line and A as the input, then what we need to connect at the input side, input of the multiplexer. (1019) CS 1019. Are you there? Okay, so tell me. So what will be the output? So what will be the input side? What will be at the input lines? What we need to connect? DC are the selection line. What we have to connect at the input side of the multiplexer to 4x1 multiplexer. This is what I keep asking you whether you understand or not, and you don't respond me. Okay. So anyone else who did not understand how to implement Boolean expression, how to take the input? Okay, we'll take same example, and this example you have to do yourself. Fine. What we need to do, whatever we have, okay, whatever okay, so we have the Boolean expression is 01467. Okay, 01467. It is in terms of the min terms. Okay, so if we have in terms of the Boolean in terms of the min terms, so that is okay. If we don't have Boolean expression in terms of the min terms, so we have to convert that Boolean expression in terms of the min terms. Then we need to prepare the truth table. We need to find out how many number of variables are involved in this in that Boolean expression. So now from this function we can say that the number of variables are ABC. It is very much clear to everyone that number of variables are ABC. So among those ABC are so number of variables are 3. So from the rules it says, if n number of variables are involved in that particular Boolean expression, we have to take n minus 1 variables as a selection line, the remaining variables as input. So if n minus 1 number of variables are we are taking as a selection line, so remaining variable will be only one variable will remain. So whatever variable is remaining, we will take that variable as the input. Prepare the truth table and modify the truth table according to the selection lines. So we have 01467. We have the truth table of this Boolean expression. So we know for the three variable, we have 8 combination and we have 8 min terms, 0, 1, 2, 4, 5, 6, 7. Okay, so we'll see for what min terms this Boolean expression is true and for what min term it is false. So from this we know that this is the sum of product of 01467. So 01467 for these min term it is true. So 1 1 1 1 1. So if we take n minus 1 is 2 here, so 2, and we know that if selection lines are 2, so what will be the order of marks we need for the we require for the implementation? It will be 2 to the power 2 is equal to 4. 4 cross 1 will be the order of the marks. Okay, for this thing we have 2 selection lines. So on the basis of this we will prepare the truth table. So here this is the truth table. We need to we just suppose that the inputs of okay, so first we'll draw the block diagram. Okay, so the block diagram of the 4 cross 1 marks is this: 1 2, 3 and 4. A, B, C, whatever are the inputs, we are not interested. What we need to attach to those inputs, we are interested in those things. Okay, so here we know that AB we are taking as the selection line, or we are in C as the input. Okay, so for AB selection line, we have how many combinations? We have 4 combinations. So for those, we will take those 4 combinations. So combinations are 0, 0, 0, 1, 1, 0 and 1, 1. And the inputs we'll take here. So input is C. So we have input, one variable is there, and which that one variable will have 2 combinations. Okay, not 2 combinations. Actually, it will take 2 values because we are talking about the binary. So in the binary, if we have one variable, so that one variable will take 2 values, 0 and 1. So that's why we are taking C dash and C. For selection line, we have two variables. So for 2 variables, we will have 4 combinations. So we are taking here 4 combinations. Okay, 0, 0, 0, 1, 1, 0, 1, 1 and 0 and 1. Now this is for selection line 0, 0. A will be selected. For selection line 0, 1, B will be selected. For selection line 0, C will be selected, and for selection line 1, 1, D will be selected. Okay, so we are taking as a input. So here we'll see will be the minterms for different combinations. So here 0, 0 is truth table actually. So 0, 0, 0, 0, it is 0. 0, 0, 1, it is 1. 0, 0, 1, 0. 0, 1, 0. Here 2 will be here. 0, 1, 1, 3. 1, 0, 0, 4. 1, 0, 1, 5 and 1, 1, 0, 6 and 1, 1, 1, 7. Okay. Now after applying the truth table, we'll see the original truth table that for what minterm this will be high. So we'll encircle those minterms. Here 0, 1 are high, 0, 1 are high, 4 it is high, 6 and 7. So now again we'll observe the modified truth table. In this modified truth table, we'll see the here if both the for first input or first combination of the selection line, we will observe both components. If both the minterms are encircled, so that input as 1. Okay. If both are not encircled, we will take that. We will connect that input with 0. Any one component is encircled, then for that input we will check for what input it is encircled. So we have for the input we have complemented and uncomplemented input. So here for complemented input we have the minterm encircled minterm. So we will take as a we'll connect that input as the complemented input. Okay. Next we'll again see here both the components are, or both the for this selection line combination are encircled. So for that we'll take 1. If we see that only one component for that particular combination of the selection line is encircled, and then we have to see for what input level, complemented or uncomplemented value, it is encircled. If it is encircled for complemented value, so that connected with the complemented input. If it is encircled with the uncomplemented, so that input will be connected with uncomplemented input. Okay, so this is the fundamental principle. So here these are the inputs we will connect with the input lines of the marks. So input lines are A, B, C, D, which is based on the combinations of the selection lines. So for the first combination A dash B dash, input is A, which we need to connect with 1. So it will be connected with 1. For A dash B, because A, B are two selection lines, so 4 combinations for A dash B. B will be selected and B is connected with 0. For 1 combination, C is the input which will be selected. So here C is connected with C dash. Will connect with C dash. For 1 selection line combination, D input is selected. This input is 1. Okay, so this is F. So this is the simple implementation of Boolean expression with the use of mux. Now this is the implementation. Okay, so for this combination, try to find out what we need to connect at the input lines of the mux. So if B, C are the selection line and A is the input. Is everything clear to everyone now? Anyone having any kind of doubt? How to take input and how to select different lines and how to modify the truth table? No? Satish, clear? A dash 1. Okay. Anyone else? One A dash 1. Okay. 1 A dash A1. Okay, fine. Anyone else who tried? Ajay, tell me. Roll number 16. Tell me, what we will connect at the inputs of the multiplexer. Rule 19, tell me. Did you try to implement? No. Okay, 1 A dash A1. Okay. 7. What we have to do? We need to find out how many number of selection lines. So two number of selection line, because n number of 3 are the number of variables. So if we take, okay, fine, this is the same. So A dash A1 0. And what? 1 A dash A1. How your inputs are coming like A1 A dash A1? Yes. A dash A10, right? Fine. Okay. So see, we need to find out, prepare the truth table according to this to table 0 to 5 6. Okay, 0 to 5 6, 0 to 5 6. Okay, right. 0 to 5 6, 0 to 5 6. This one, this is 0. Okay, we'll see B, C are the selection line. So 4 combinations. A is the input, and a small a, b, c, d are the inputs of multiplexer 4 cross 1 multiplexer based on the combination of the selection lines. So input A for the combination B dash C dash, input B it will be for the combination B dash C, input C is for the combination B C dash, and input D is for the combination B C. So now we'll see what we need an expression maintain. Okay, that's why we are connecting something with those inputs. So 0, 1, 2, 3, 4, 5, 6, 7. So we know that these are the min terms for this variable combination ABC. Now 0, 0 to 6, 7. 0 to 6 to 5, 6. Now we'll observe for this first selection line combination B dash C dash. Here if we observe only A dash component is encircled, so we'll connect A dash with the input A. Okay, here if we observe for A it is encircled, so we'll take A as the input for we'll connect A with the B. Okay, for the next combination both are encircled, so one will be connected with this next input. Here for D, nothing is encircled, so 0. So the inputs will be A dash, A, 1 and 0. So the implementation is like A dash, A, 1 and 0. So suppose D0, D1, D2, D3 or A, B, C, D. Anything we can take as input. So we just need to connect what we need to connect, so that the whole this whole Boolean expression will be implemented with the use of this mux only. So this is the implementation. So what I have already said that multiplexer is also called as universal combinational circuit, not universal gate. This is a difference. NAND and NOR are called as universal gates, and multiplexer is called as universal combinational circuitry. So if we say if we use the term universal, that means any kind of circuitry or any kind of Boolean expression or any kind of or the basic gates can be implemented with the use of only that particular circuitry. That's why we call this as a universal combinational circuitry. So that means all standard logic gates can be implemented with multiplexer. So first we will see how we can implement the basic logic gates. Okay, we know that how to implement Boolean expression. So if we can implement any kind of Boolean expression, so there is no difficulty in implementing any of the. So we'll see that there are 3 big logic gates. And or. Everyone please enter your roll number in chat box. First, how to implement NOT. So if we input and X is the output. If A is input is 0 for the NOT gate, A is 1 or input is 1, output will be 0. So can you tell me what kind of must we need for the implementation of the NOT gate? What will be the order of this multiplexer? Tell me. Yes, 2 cross 1. If we apply the same rule that after implementing this truth table, if we apply the same rule that if n number of variables are there, n minus 1 will be selection line. So how many number of selection line and how many number of input line? So here this is the exceptional case, the NOT gate, in the sense that the number of input and the number of selection lines are same in case of NOT gate. Okay, so here if the selection line is A, 2 cross 1 mux we need, actually 2 cross 1. So if 2 cross 1 mux is we are taking, this is A, this is B. So what we need to connect here so that it will behave as the inverter. Okay, so here if we say this is A, okay, so if A for one variable it takes two level, so it for this selection line it will select two inputs. Okay, so if A is 0, small a will be selected. If B is 0, small b will be selected. So here what should be the output? For if A is equal to 0, it should give output as 1, and for B, if A is equal to 1, it should give 0 as the output. So from this truth table, if we connect directly A with 1 and B with 0, this will behave as the NOT gate. Okay, so simple implementation of the NOT gate with the use of 2 cross 1 mux. Can you try to implement the AND gate and with the use of mux? 2 input AND gate actually. Okay, so we'll see 0 0 4 combination, 0 1 and 1 1. Okay, so for AND 0 0 0 1. So what will be the inputs? What we will connect with the input? At the input side, or tell me. Selection lines will be what? 2, 1. Okay. So selection lines will be 1 selection line. So suppose the selection input. Okay. So here what we have to do, we need to modify the truth table. Okay. So the modified truth here B dash B. Okay. So this circle. So here 0 and A. So the implementation will be like this. If we take 2 cross 1 mark, so for B dash to connect, and this is the output. So this is the implementation of the AND gate with two input AND gate with the use. Everyone, please try to find out how to implement NAND and NOR with the use of marks. Okay, so we'll take only two input. We'll start with the so how to implement any kind of Boolean expression or anyone left? How to design, how to implement how to implement Boolean expression with the marks, and how to implement no. Okay, so then encoder.